Today we are talking about 8-4, adding and subtracting fractions. And number one is a very basic problem, something you could have done back when you were in elementary, when you first learned how to add and subtract fractions. And the way to do this is not plug it into the calculator and get the answer, because we can't do that with the Algebra 2 problems. So we're going to go back to the basics on how you add and subtract fractions. When you add and subtract fractions, there is a golden rule. You must have this thing before you're able to actually add or subtract. What is the thing that I am talking about? Yeah. Common denominator. This is where common denominators matter, adding and subtracting. So that's our very first goal. The very first thing we need is a common denominator. Need to get that. And from now on, I will just write CD for common denominator, because I'll write that on every problem. Our denominators are 3 and 5. An old rule of thumb that always works is you can just multiply them together to get that common denominator. And sometimes that is the only option that you have. This problem, that's exactly what we want to do. We want to be able to turn 3 and 5 into the same number. That number would be 15. So I'm going to write down my goal fractions real quick. My goal is to have both of these be a fraction with 15 on the bottom, plus in the middle. Now we have to ask ourselves, fraction at a time. First fraction, how do we turn this 3 into a 15? 3 times 5. With a fraction, whatever you do to the bottom, you have to do to the top. So we multiply top and bottom by that 5. So 5 times 2 on the top, we now get 10 over 15. And then for our second fraction, to turn 5 into 15, we need to go times 3 on top and bottom. And we end up with 12 over 15. Now that we have a common denominator, we can actually add these together. First off, how do you add fractions? Just across. Which part? Just across? Yes. Just at the top. So the 15 stay the same. We don't turn that to 15 plus 15, which is 30. It's just 15. So unlike multiplication, which we did last week, we do not do the bottom. The bottom will stay the same. And we just add the top like normal. 10 plus 12 is 22. One last step, just to make sure that we can't reduce this, we can use our calculator to check for that. That's just with our ABC button. 22, ABC, 15. And it's going to give me that mixed number first, so we're going to have to convert it. Second ABC, if you have the white calculator, it's shift ABC. And you should get 22 over 15, meaning we can't reduce. This is our answer. And that's how you add fractions. This is the basic concept we're going to be doing, but in an Algebra 2 concept. Number 2. 3y over 2x cubed plus 5z over 8xy squared. First thing we need is a common denominator. Something to think about. You can never take something from the denominator. I can't remove this y squared because that would make my life easier. Or remove some of these x's here so that it matches that one. You can't take things away. You can only give it things, add things to it. So we need to see what collective denominator I can turn both of these into. We start with the numbers and then we go with each letter. First, let's look at the numbers. We have 2 and 8. We can easily turn 2 into 8. 2 times 4 is 8. So our common denominator has an 8 in it. Next, we look at the letters, and we'll go alphabetical order. Reminder, we can only add to it. We can't take away. We have x cubed here and x here. So I'm going to write down the larger one because I can always give it more x's. That's an option. And then this fraction has a y squared, so that has to go in there as well. So our common denominator is 8x cubed y squared. To give myself more space to show the work, I'm going to write the problem again. 3y over 2x cubed plus 5z over 8xy squared. And let's go ahead and write the goal fractions with the common denominators already set up. Common denominator is 8x cubed y squared. And of course I have the plus. Now we can just look at each fraction and ask ourselves, what do we need to multiply by to get to that? Let's start with the 2x cubed. We need to turn 2 into 8. That can be done with a 4. 2 times 4 is 8. We already have the x cubed, so we're good there. We just need that y squared. So I'm going to give it a y squared as well. That means I'm going to multiply the top by 4y squared to make this work. These are monomials. We learned about that last unit, so we know how to multiply those. Multiply the numbers, and then when you do the letters, you add the exponents. 4 times 3 is 12. And then the y's, we have y squared, and this is y to the first. So when I add those exponents, I get y cubed. I'll do the same for the other fraction. Let's see what we need. We already have the 8, so we're good there. We need more x's. We have 1 x right now, so we need 2 more to get to 3. So we need x squared. And then the y squared is already there, so we're good. All we need is an x squared to make this work. Multiply top and bottom by x squared. On the top, we're just going to put all of this together in alphabetical order. 5x squared z. Now I want to pause and make a couple points here because here's where some of those old habits are going to kick in. First off, looking at this, I'm sure you see the 12 and the 8, we can reduce that. The y's, we could cancel that. The x's, we could cancel that. You're so used to canceling, but that's not what we're doing on these problems. If you go through and cancel all of that like you're used to, you're going to be taking a step back. We're going to be going back to the original problem, undoing all that work we just did. So whatever you do, do not cancel on these problems. At least not at this part of the problem. We're rarely going to give you a problem that involves any level of canceling to avoid that mistake entirely. So don't focus on canceling at all. Next thing, the adding part. Let me show you what this does not equal. So if you don't want to write this down in case it might cause issues, you might do this on accident instead. Maybe just watch. Let me show you what the answer is not to this. Can someone tell me why that is wrong? Remember, we are just adding. What are the rules of adding? Does nobody see the issue? Let me give you a much simpler example. Tell me why I can't add those. Different variables. If the letters don't match, you cannot add or subtract. You can multiply. That's why we could do it all the time last test. But in this unit, if the letters are different, you can't add. So, looking at my two numbers, 12 has y's, 5 does not. 5 has x's and z's, 12 does not. On top of that, the letters and the exponents all have to match. It has to be the exact same. We're not even close. So, on a problem like this where you can't actually add, we're going to add without actually adding. Just like last unit, we quote unquote multiplied, but we didn't really multiply. It's that same thing. All you do is put it together in one fraction, and we're done. 12y cubed plus 5x squared, z. All over, you only write the denominator one time. 8x cubed y squared. That's our answer. Moral of the story, sometimes you can't actually add, and that's okay. Just make it a single fraction, and then you're done. This won't happen very often, but it will happen sometimes. Questions on number 2 before we move on to number 3? Okay. Number 3. This on the surface looks like a harder problem. It is not. This is actually, finding the common denominator is so easy here. Just give me a minute. 2 over x plus 3. Let's put that x plus 3 in parentheses like we're used to doing. Plus 3 over x minus 4. Same thing. Let's give it some parentheses. There is no way I can turn this 3 into a 4 or this 4 into a 3. It's not possible. The only thing I can do to get a common denominator is to put both of them in the denominator. Use both parts. So, my common denominator is x plus 3, x minus 4. Again, I'm going to rewrite this to show the work. Give me some more space. 2 over x plus 3 plus 3 over x minus 4. I'm going to go ahead and set up my goal fractions with the correct denominator. So let's figure out what we need to do to change both of these into the common denominator. First fraction has a denominator of x plus 3, and it's missing the x minus 4, so let's give it that. Times x minus 4 times x minus 4. So the bottom's already taken care of. On the top, we have 2 times x minus 4. Just like the last unit, 2 is a monomial. It's its own number. We're just going to put that in front. So 2 and then x minus 4 after it. Right fraction is going to look like the same thing. X minus 4, we're missing the x plus 3. So we'll multiply top and bottom by x plus 3. And then on the top, I'll write 3 times x plus 3. Now that we have common denominator, we can add. Write the denominator one time. X plus 3, x minus 4. By the way, I never advise you to multiply the denominator. It doesn't change a thing, and that creates a lot more work for you, so leave the denominator alone. The top, however, when there is multiplication present, in this case, we call this distribution, you do want to do that because you might get some terms that you can then combine, some like terms. So in this next step, to save me some work, I'm going to go ahead and do that distribution. So I'll distribute that 2. 2 times x, that's 2x. 2 times negative 4, that's negative 8. I'll bring down that plus in the middle. And distribute the 3 on the right. 3 times x, that's 3x. 3 times 3, that's positive 9. One more step and then I'm done. We do have some like terms here. I hope you see them. We have a pair here with the x's. We can add those. They have x on them. 2x and 3x, they're both positive, so we'll just add. That's going to give me 5x. And then I have minus 8 plus 9. Negative 8 plus 9, that's positive 1. 5x plus 1, and then don't forget the denominator. X plus 3, x minus 4. And there's our answer. If you forget the denominator in your final answer, it will be counted as wrong, just an FYI. Questions on number 3 before I move on to number 4? Number 4, I want you to pay extra close attention. Subtraction. Subtraction has an extra step to it at the beginning that if you don't do it, it will mess up the rest of the problem. When you're subtracting with algebra, it makes things more difficult. So my trick is let's turn it into an addition problem to make it easier. Let's turn that minus into a plus. And before I do my next part, I'm going to put parentheses like I normally do. And that will help with what I'm about to do. We still need to account for that minus somewhere. So what I do is I put a negative 1 on top of the next fraction. That is kind of the replacement of the minus. To make that a bit more clear, I'm going to rewrite the problem. I'll do it anyway. We have 5 over 2 times x minus 1. This is now a plus instead of a minus. Plus, and then the next fraction, we have that negative 1 on top times the x plus 1 over x minus 1. This is the problem we're solving now. Common denominator. The denominators are almost exactly the same. We're just missing a 2 on the right one. So we're going to use the left denominator, 2 times x minus 1. And then we can easily make the right fraction match. So let's set up our new fractions with the goal, the common denominator on it. 2 times x minus 1. 2 times x minus 1. The left fraction is already as it should be, so I don't have to make any changes. The denominator is already correct. The right fraction just needs the 2. So I'm going to multiply the bottom by 2 to make that work. And I'll do the same thing to the top. Now I can multiply on the top, and this -1 is a monomial, so I can multiply that by the 2. So I'll do that to start. -2, and then bring down the x plus 1 on top. And then don't forget the plus. From here, this is going to go just like the last problem did. We can now make these one fraction instead of 2. So we'll have 2 times x minus 1 on the bottom, our common denominator, right at 1 time. I'll bring down the 5, and then the plus. And we have a distribution problem on the second fraction, so I'll do that. -2 times x, that's -2x. -2 times 1, that's -2. One last step here and we're done. Bring down the common denominator, 2 times x minus 1, don't forget it. I have one pair of like terms, 5 and the -2. I'm going to write the -2x first, -2x. And 5 minus 2 is 3, so plus 3. This is my final answer. Questions on number 4. I hope you think this isn't too bad. I don't think it's too bad. I actually find this a bit easier, but at least faster than the multiplying. I definitely spend less time on these problems. Okay, we got 2 more. As promised, I'll do 5 and 6 and then we'll be done. 5 and 6 are the same thing, but now we have factoring added to the mix, which we've done a lot of factoring over the past week, so we're in practice. Whenever you see factoring, that's the first thing you'll do. Because typically once you factor, then you can clearly see the common denominator. So on this one, I'm going to make a note here. Factor first. If you can factor, do it. Then do the process. Number 5, we have 4 over x squared minus 9 plus 7 over x plus 3. I'll put that x plus 3 in parentheses as usual. And I'm not going to do that to x squared minus 9 because I can factor that. How do I factor x squared minus 9? Give me the shortcut, please. Chase?
Square root.
Yes. Square root. Front and back. Leave the negative in the middle. Difference of squares here. Don't forget you have 2 factors. 2 sets of parentheses, not 1. That's because we have the plus and the minus. You have to create the 2 cases. Square root of x squared is just x. Square root of 9 is 3. So we have x plus 3, x minus 3. Let's identify our common denominator. We're going to ignore the x squared minus 9. This is the new denominator. Compared to just x plus 3, the only difference is one of them has x minus 3, the other doesn't. So this is going to be our common denominator. X plus 3, x minus 3. To do the work, I'll write the problem again, but with the new denominator on the first fraction. We have 4 over x plus 3, x minus 3, plus 7 over x plus 3. I'm going to create the new fractions that I'll make in just a moment. Common denominator, x plus 3, x minus 3. Bring down the plus. The first fraction is going to stay the same. Denominator is already correct. Second fraction is missing the x minus 3, so I need to give it one of those. Multiply top and bottom. And on the top, I'm just going to put those together for now. 7 times x minus 3. Now that they have the same denominator, I can properly add them. Write the denominator and write it one time. X plus 3, x minus 3. First fraction, I'll just bring down that 4 and then the plus. Second fraction, we can distribute once again. So I'll do that now. 7 times x is 7x. 7 times negative 3 is negative 21. One more step and then I'm done. Go ahead and bring over the common denominator. X plus 3, x minus 3. I have a pair of like terms. I hope you see them. We have the 4 and the negative 21. I'll write the 7x first. 4 minus 21 is negative 17. 7x minus 17 on the top. This is our answer. Questions on number 5 before we do our final problem? All right, last one, number 6, has some more factoring here. Negative 4 over 5x plus 10 minus, we're going to have to deal with that in a moment, 2x minus 1 over x squared minus x minus 6. I'm going to put this binomial up here, 2x minus 1 in parentheses. That is not a factoring problem. Reminder, when you see a minus, fix it. We're going to change it into a plus and then put a negative 1 on the top of the next fraction to fix that. Now it's no longer a minus. Next, we're going to factor. We have 2 factorings to do, one in each denominator. 5x plus 10. We can factor this. What kind of factoring problem is this? What do we always look for first? Anytime we look at a factoring problem, I always ask you to look for this specific thing. It's 3 letters. What's it called? Yeah? GCF. Thank you. Always search for that GCF. 5x and 10. You can divide both of these by 5. Divide them both by 5. Don't lose the 5 though. Bring it down. 5 comes out. It doesn't disappear. And the parentheses will divide. 5's are gone here. Now it's just x. Plus 10 over 5 is 2. There's the first factor. Factoring. Next problem, x squared minus x minus 6. We have 2 of these are 1. No GCF here. This is your typical ACB chart kind of problem, trinomial. I'm going to set up the factors first. Got my x's in place. ACB chart, A times C on the left, B on the right. A times C, 1 times negative 6, that's negative 6. Since it's negative, we're subtracting on this problem. B is negative 1. Factors of 6, 1 and 6, 2 and 3. And we want to subtract to get a 1. We can do that with 2 and 3. Reminder, when you have subtraction, I want you to show both ways just to make sure you pick the correct pair. 2 minus 3 is negative 1. 3 minus 2 is positive 1. And we want negative 1. So it's positive 2, negative 3. The factors are x plus 2, x minus 3. That was a lot all at once, so I'm going to take a moment, take a step back, and write the problem again, but with the new information. We have negative 4 over the new denominator, 5 times x plus 2. Remember, we changed this to addition, plus, on the top we have negative 1 times 2x minus 1. On the bottom we now have these factors, x plus 2, x minus 3. This is the current problem that we're looking at. Now let's identify the common denominator. Looking at both fractions, and this is collectively, just looking at them together. We have a 5, so that has to be included. They both have x plus 2, so that has to be included. And then the right fraction has an x minus 3, so that has to be included. Again, we can't take things away. So if it's there in the denominator, it has to be part of the common denominator. Let's set up the new fractions with the correct denominator. Five times x plus 2 of x minus 3 on both fractions, plus in the middle. And now we just have to figure out how to fix both of those fractions. Fraction on the left is only missing x minus 3, so that's what we're going to multiply by, top and bottom. For now, I'm just going to put these together, but put the negative 4 in front. Negative 4 times x minus 3. Second fraction just needs that 5. So times 5 on top and bottom. And I can multiply the 5 by the negative 1 in front, so that's what I'll do. It's now negative 5 to x minus 1. 2 steps left, and then I'm done. We're almost there. Now that I have the common denominator, I can properly add these together. Write the denominator right at one time. 5x plus 2, x minus 3. On the top, I have 2 distributions to do. So I'm going to do both of those. Starting with the first one, negative 4 times x, that's negative 4x. Negative 4 times negative 3, that's plus 12. Plus negative 5 times 2x, that's negative 10x. Negative 5 times negative 1, that's positive 5. Lastly, we look for like terms. I'm going to copy over the denominator first. 5 times x plus 2, x minus 3. Don't forget it in your answer. And now for the like terms. I've got a pair of x's here. Negative 4x and negative 10x. Negative 4 and negative 10 give me negative 14x. And plus 12 and plus 5, both positive. 12 plus 5 is 17. Negative 14x plus 17 is our answer.